So on the previous lesson, we learned about 3D sketches. Now we're going to learn how to create a weldment out of that 3D sketch. The benefit of using the weldment tools in SolidWorks is that it can save you a lot of time. Because traditionally, the way this was built was by using bottom-up assembly, which was to create models for each of these members, putting them onto an assembly, and creating a part drawing for each. But that was kind of tedious because anytime you needed to change something, let's say you needed to make this longer, then you need to update all these other models and you need to update the drawings, and it was really tedious. But with the weldment tools, what's cool is that you just create a 3D sketch, you generate a weldment out of it, as shown here, and then you can generate a weldment cut list, which is nice because anytime you need to update, all you gotta do is just update the 3D sketch, and then all the members will change, all of their lengths will update, and the weldment cut list will update as well. This cut list shows you the sizes of each member, how long they are, so it's kind of cool because in just one drawing, you can get a quote for this weldment. Okay, you just send this drawing out and you're done. You don't have to create a packet of drawing. So before we can understand how to model a weldment, we need to understand how to design one and understand what it is. So a weldment is pretty much a structure where all the stresses are held in the machine. So if you think of a car, the weldment is where you would jack the car, okay? You don't jack the car on the tire or on the sheet metal. When you connect the engine, you don't connect it on the sheet metal. You connect it on the frame. The seats, the wheels, they're all connected to this weldment. So this is a very important structure. It's where it starts. It's the I-beam structure of a skyscraper. And you got to answer a couple questions. The first question you got to answer is, what kind of material am I going to choose? Don't pick something crazy. Again, pick something off the shelf. Steel, stainless steel, carbon steel, bronze, and aluminum are very common. But my favorite is just a regular steel with a gray machine paint. This is one of the most common ways of designing a weldment, and I highly encourage you to use it. So again, just a regular steel with a gray machine paint. The next question you got to answer is, what kind of profile do I want to choose? Is it an 80-20 extrusion? Is it an I-beam? Is it a square beam? So again, my recommendation is to pick something that exists. That should be one of the very first steps. Go to the catalogs, the bar stock catalogs, pick a profile that exists and is abundant, and even call the fab shop, call the person who's going to make it, make sure they have that profile in stock. You should do that before you start any kind of design, any kind of drafting. You should make sure that all these structures exist. The next point is on the joints, okay? If you have an orthogonal joint, I encourage you to just cut it 90 degrees and butt up the end points, just like you see here. Don't cut a 45-degree end mitter. The mitter is okay for like an angled structure where you have like a 30-degree pick off on a 65-degree or something like that. That's okay to cut it like this, but if you're doing an orthogonal joint, don't do that because this is more complicated than this. This you gotta worry about the angle. A lot of times you get a little bit of overshoot on the end and you have to grind it down. It's not very clean. So I encourage you to use this. It's much more inexpensive, much more easier. The next thing you gotta think about is the welding. There's a lot of welding on a weldment, and you can go crazy about the weld specifications. There's all kinds of weld symbols out there, like, you know, what's the size of your fillet bead? What kind of groove do you want to cut? What kind of post grind operation do you want to post? Do you want to weld this outside in the field with a flag indicator, or is this going to be welded indoors? So I try not to go crazy with these symbols. Again, I usually just talk to the fab shop owner and their welders. I talk about what I'm looking for, and they kind of know what to do from there. So I used to go crazy with these, but I kind of stopped doing that. For weldments, it's not a precise welding application. I just kind of talk to them. I do some super generic symbol, and that has worked really well for me. With weldments comes gussets. Gussets are very common with weldments, and really they're just a way to reinforce the joint a really bizarre angular joint needs to be reinforced with the gusset plate, as you see here. So I encourage you to include a gusset plate and design them to be permanent. I used to design them so they could be removable, but a lot of times that added a lot more complexity than I needed. I thought that the weldment would need to be modified long term, but that is very rare. You know, a machine usually they're designed to last for 20 and 30 years, and the weldment is not one of those things that need to be changed often. I mean, the programming needs to be changed, the controls need to be changed, fixtures need to be changed, but the weldment is pretty solid. So don't worry about making it removable. I encourage you to make the gussets. On the end connections of a weldment, it's a good idea to put an end cap for ergonomic reasons, okay? And also to prevent dust and dirt to slide inside the weldment, because again, these machines are very heavy, and really you're not gonna take the time to flip the machine upside down and remove all the stuff inside. Okay, these machines are designed to just stand still, like what you see here. So it's good to put an end cap to just make to maintain the hygiene and the ergonomics of this machine. At the bottom of the weldment, you should include a leveler. So on the top and on the side, you should put an end cap. On the bottom, you should put a leveler. And this really just makes sure that the machine is level to the floor. So you can modify these nuts and you can adjust the height so that the machine is flush and straight. You can also include wheels. I've seen that done a couple times too. You can either put a leveler or wheels if you need to move it around frequently. Or if it's like a small like benchtop machine. Hoists are something I also like to spec on the top of the machine. Usually what I do is I look to see where the center of gravity is, which can be done in SolidWorks, and then I spec a through hole and say bolt a hoist at that location. So the reason I do that is because sometimes when they want to lift the machine on a mezzanine, they don't use a forklift for that. They use a crane. And instead of trying to, wrap the crane around or the hooks around or strap their crane to some features of this machine and try to figure out if it's going to be stable. Instead of doing that, I just place a hoist, and this way it's a very easy hook. It's a very easy connection, and they can lift the machine with the crane. So when you design a weldment, okay, I encourage you to use the SolidWorks weldment tools, which is what we're going to learn in today's lecture. It's a tool that lets you generate a frame given a 3D sketch, and it's very easy to use, very easy to modify, but at the same time it doesn't give you as much control as bottom-up assembly, which is a technique I used to use to create weldments, where you import each piece one at a time and you mate the pieces together. If you have something complicated like this, like the hull of a ship, you're not going to use the weldment tools for that. It's just too complicated. You need much more control over the joints, over each component. There's no way that you can pull this off with the weldment tool. So what I'm trying to say is you got to look at the complexity of your machine. If it's really complicated, just resort to the ancient methods of bottom-up assembly, where you create each part one at a time, you mate them together, and you build a structure. But if it's some benchtop equipment like this, I encourage you to take advantage of this weldment tool set. Finally, I just wanted to show you a couple photos of weldments that are getting manufactured. So the process is you send them, the weldment, you send them the drawings and the weldment cut list and things like that. You get them quoted, then you put in a purchase order, and then as an engineer, you got to visit these sites. You got to make sure that they're doing the welding okay. So every week they're going to have an update and they're going to ask, hey, can I do this and can I do that? And you got to say yes or no. So this is the part where you got to make sure everything's coming together, everything's looking all right, and everything is to spec. Because again, remember, as the engineer, you got to make sure this machine's going to work right. So you got to make sure you make the right decisions on the questions they might ask you. So to start this, we are given a start file. Okay, it's pretty much the 3D sketch that we built on the last structure. And what we're going to do is turn this into a weldment. So to start, we have to turn on our weldment tools, and this is what they look like. Okay, so we're going to kind of talk about these buttons. So the first thing you got to do is you got to generate the weldment. So this is called the structural member tool. Alright, tells you the standard, the type. So it's kind of cool because you can pick like an I-beam or a pipe or anything like that. And it kind of figures out how the joint is supposed to be cut. So that also saves you a lot of time because otherwise you'd have to use the extrude cut tool, the revolve tool, and that could be kind of tedious. So today we're just going to pick a square tube, and it's going to be a 4x4 by 0.25 width, length, and thickness. But one thing you got to understand is make sure that this structure exists in the industry. Alright, make sure that when you go to a supplier site, okay, make sure that the structure exists. Okay, for the width, for the length, and all that stuff. And make sure it's abundant. You may even want to talk to the suppliers and see, hey, do you have this available? You don't want to spend all this time designing and realize that the structure doesn't exist, and then you gotta start over and waste all that time. So make sure to do that verification before you start selecting the cross section. So once you figure this out, you're ready to build a weldment. You do that by creating groups. You can create as many groups as you want, but only have one structural member. So if I hit new group, you got to pick entities that are consistent. You see that? Don't pick like this and that's, see, it's not even letting me select it because it's glitching out. So you got to pick entities that are consistent with each other, okay? Don't be shy about creating more groups if you have to. Okay, so I'm going to set one group as the floor. I'm going to set one group as the ceiling. Also, try to stick to end butt as much as you can. See this end butt? It's just a lot easier to manufacture that than an end mitter. Alright? If you don't need an angle on... If it's at an angle, you do need the end mitter. But if it's at an... Also, make sure to select the end butt when you have an orthogonal angle like you see here. Try not to pick an end mitter for an orthogonal joint because it's more effective, it's more efficient to use that. If you do need an angle like at a 45, then you do need to use the end mitter, but not when it's orthogonal. Okay, so this looks pretty good. I'm gonna add another group for this member. Okay, then I'm gonna add another group for this member. See, I always tend to get problems with these angles, so that's why I try to just keep it as one separate group. Okay, that's a good start. Click OK, and then this is what you get. So let me kind of clean this up so you can see it better. So I'm actually gonna hide all the construction lines, but this is what you get after you complete the structural member. So the next step is to fix the joints. They have to look exactly like what you see here. So for instance, you see this bar go all the way up to the ceiling. Alright, you see this bar go up to the side. So we gotta kind of trim that up, and that's done with the next button here. It's called trim and extend. And here's how this works. You got two boxes. First box is what you want to extend. Second box is what you want to extend it to. So we're gonna pick this and make it go up to this. Oops. You gotta pick the right end butt. So this all the way up to here. You can switch between the two to get the right effect, but that's really the idea. Okay, let's click OK. Okay, I'm gonna do this again for the next one. This one up to here, and there it is. Okay, I'm gonna do it again. This one up to here. All good. Alright, this one's alright. This one needs work. This one needs work. Let's see, what's this one? This one is okay. Alright, this one needs to switch, so let's see. Sometimes you gotta do this in multiple steps. Let's see what this gives us. Okay, so that's alright. Let's see, this one, I don't remember. Okay, this one takes precedence, so this one's gonna bypass this one. Okay, so this is good. Alright, now we gotta work on these two. So this one's probably going to be done in 2 steps. I need this to extend through. So let's see. If I can make this extend this one out, that would work. And then I'm gonna make this trim up against that. You see? So it's just mix and matching. Mix and match what you select, mix and match the number of steps you use to complete the joint, and mix and match these two end butts, and you should get the joint that you need every time. Okay, so finally I have this one here. And I'm going to, let's see, I'm going to first bring this one up to there. And then I'm going to bring this down. Let's see if we can do this. There we are. You see exactly what I want. This makes sense. See, it's cut exactly to that surface, to that angle, and then you may end up welding it. You put a little weld on the back so it stays in position. On all those joints need a weld. So the next item is to add end caps. Okay, usually I import these from a supplier site, but sometimes I like to use this tool as well to make this process a little easier. So again, this is a little bit for ergonomics. Okay, you don't want things to slide inside the structure. Okay, one for each. Anything that's exposed needs an end cap. You just don't want things to get inside of there, okay? You want the insides to be kind of clean, because again, no one's going to flip this machine upside down and remove all the stuff inside. I mean, these are pretty heavy machines. Once they're designed, they're anchored, you know, they're not going anywhere. On the bottom, you put a leveler, okay? Or wheels. You can either put wheels or a leveler, depends on the machine. And again, a leveler lets you kind of level the machine so it's flush or it's flat to the ground. Okay, so we're going to add a little bit more thickness on this. Let's see, 0.5 maybe. And then 0.25. And I'm going to add a little corner treatment here for 0.375, actually. Let me put, oh, this is the offset. Okay, I'll put a 0.75 offset. Okay, just so it's a little cleaner. All right. There are some that you push on, there's some others that you screw on, some that you weld on. Okay, so they got different styles. Alright, so that's the end cap. Another thing you may want is like a little gusset plate to reinforce the joints. And the way you can add these, I mean, this is just a simple triangular gusset. You just gotta select the insides of the gusset, and then you can spec some values. I'm just going to put a 6x6 gusset, and I'm just going to change this thickness to 1 inch. Okay, just a solid gusset that you can weld, alright, onto the machine. Alright, I'm going to add this on the other side as well. So there's our little gusset. Same deal. Reason I'm doing it twice instead of mirroring is sometimes when you mirror, it fuses the gusset onto the weldment, and it gives you problems when you create your weldment cut list. Some engineers also like to put a little weld inside here. Let's be done with the fillet bead. If I remember right, you gotta select these two, and then you gotta select the side faces of the gusset, and as you can see, a little fillet bead shows up. Okay, so there's just really two boxes, and then if you want, you can make this a little bigger. Okay, so I'm gonna add this on the other one now. So it's 1, 2, and this one's 1, 2. And then when we click OK, let's see what we get. There it is on the other side. Okay, so that's the weldment. Now what I'm gonna do is turn this into a cut list on a drawing. Alright, so to do that, the first thing we gotta do is we gotta update this. So I'm gonna right click and hit update. It's the cut list. You gotta update it for the weldment cut list to work. Okay, then. So first thing I gotta do is save this. Okay. And once we do that, once we've updated the cut list, once we've saved it, now I'm gonna create a drawing. Just a regular drawing. We're not gonna put a template. Let's see if I can. So I'm just projecting this view just like anything else. I'm gonna hide all those extra lines. I'm gonna change this to shaded. I'm gonna make this a little bigger, and I don't like those tangent edges, just hard to read. Alright, that's a lot cleaner. So to create the cut list, all you do is you select the view, and then you go insert tables, weldment cut list, and it figures out all the members, figures out their length. So this is really good because then you can just send this to a customer, and then you have to update you have to add the balloons as well. Okay, so you gotta put a balloon here. Okay, I put a quantity. Well, quantity is not so relevant because these members look so similar that you don't want anyone to assume. You want to put a balloon on each member so they know exactly what the length is. There's no assumption made. So I encourage you to actually put a balloon on every member. It's a little different than a assembly bill of material. This is a weldment cut list, so the rules on the balloons are a little different. Okay, and you can even clean up where that location is. You can change that, or you can change the location of that. So you can clean this up so it looks like the final product. Okay, so it looks like this. Okay, as you can see, the balloons are there, everything's there. Let's say you wanted to populate the items here. This is really just talking about the end caps and the gusset. The way you do that is going back to the model. Okay, you can do that by opening part here, or since it's already open, you can also select it from here. So either way, you can go back to the weldment. And to do that, you gotta go to this cut list here. You gotta select the gusset folder and hit properties. And then you gotta add a description that matches it, which is description. And you can put ABC or whatever description you want. And then when you go back to the drawing, as you can see, ABC shows up. So you can really modify this any way you want. But don't hard code anything. Don't hard type any text in these boxes. It should all be generated from the properties of the model. So that concludes the weldment tutorial. Okay, and on the next exercise, we will learn how to add sheet metal to this.